Exponential functions. So we must have seen these in algebra. What is the root word for exponent? Exponential. Exponent. You could have said the root word is that is the root word. What does exponent mean? If you're exponentiating something, what does it mean? No one can't hear. Raising it to the power, raising what to the increasing something in a multiplicative fashion. So we all know x squared, x cubed, x raised, and we have raised something to the power. All this time, nothing wrong with it. They are exponents in a way themselves. Each of those increase multiplicatively in the sense, if you start with x, multiply x to itself, you get x squared. Very good. 1 multiply to itself by x, get x. Multiply by x again, x squared, x cubed, and so on. So this is something you've done, we have done before. So how do we differentiate this from an exponent? Suppose I have number 2 raised 0, which is simply 1, correct? I multiply it by 2 ones, I get 2. Multiply that by 2, I get 2 times 2, which is 4. Just like x times x is x squared, 2 times 2, 2 squared. Multiply 2 squared by 2, you get 8, which is 2 cubed, and I can keep on going. If I kept going, let's say you multiply that 1 by 2 to itself, n times, this last term has to be 2 raised n, just like x raised n. Yes? But instead of saying n times, if I multiply 2 to itself, x number of times, starting 0, I can write it as 2 raised x. Good. Put me so far. If you notice, x is in the power of 2. Unlike that expression where you have x raised to the power of 2. Then it is a polynomial. Here it is an exponential function. That is a polynomial function of degree n. This is simply an exponential function. Good? Now, let's make it answer. We always define exponential functions or a function as y equals f of x. In this case, 2 is getting multiplied to itself x number of times. We end up getting 2 raised x. Yes, that is a very specific case. I took 2, I multiplied to itself, I ended up getting 2 raised x. My favorite number is 2, so I'm going to do 2. Stephanie, what's your favorite? 7. You can multiply 7 to itself x number of times. you can get 7 raised to x. Yes? Okay, what's your favorite? Okay, let's see. Sarah, what's your favorite number? 12. You can multiply 12 to itself x number of times. You can get 12 raised to x. The point I'm trying to make is that number could be anything you want. Yes? You can even put 1 point. All time. That's not 6. That's the letter B. I'm not funny. B. Yes? Not 6. B. B is called here is my mantra I stole from Megan Trainor. All about the base. And my mum didn't have to tell me, I just knew. B raised x. So you can vary B to be any number. It could be 2, pi, 1.2, negative, doesn't matter. In this case, let's specify the case. B is 2. So B is the base, the x is the exponent. So B raised x is an exponential function. That is the general form of an exponential function. Good. In math, we have something called the natural base. The natural base is the number E. We all know E is a letter in the alphabet, but it's also a natural number. Do we know what its value is? Pick up your calculator. You should say E raised x. Type E and raise it to the power of 1. You will get the value 2.8, excuse me, 2.781. No, 7181, no, 28. We don't terminate it. It simply put dot 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 because just like pi, 3.141 keeps on going. Why is pi so unique? Why do we have to define it in a certain way? What is special about pi? It never ends. What is it? Okay.
Pi never ends.
Pi never ends.
Like, it's a continuous
One of those three doesn't either. It's 1.3. I can put words for it. What is the difference between 1/3 and pi? It doesn't repeat in a fashion. If you do 1/3, 0.33333, please repeat it. But you won't find a specific pattern in pi, no matter how many digits you go through. Don't know if you've done this in earlier life. You do decimal and then you put a dash in front of it. If it is 2 repeating digits, you might write it as 0.67 dash on top. It's 0.676767. Something that you cannot do with pi because there is no underlying pattern. You cannot do with E, there is no underlying pattern. There is another rational number, irrational number. Do we know? It has something to do with 2. Square root of 2. square root of 2 is also irrational. 1.4, 1.4, and 2.8. Are we clear? So E is the natural base. So when we write y is equal to E raised x, this is simply a natural exponential function. So in math, when we talk about exponential functions, naturally we go to e raised x. If they don't specify the base, it is always e raised x. Good? Okay. The number 2.71828 keeps on going. Is that positive? That's an easy question. Yes. If you take a positive number and you raise it to some power, namely 0, -1, -5, 1/3, +5, 15, doesn't matter, would you get a negative number? No. If you have a positive number and you're raising it to the power of something, no matter what goes for that value x, e raised to x will never be negative. Agreed? Okay. Is there a value of x which would make e raised to x go to a positive infinity or negative infinity? In the sense, is there a value which would result in divide by 0? Got to plug in something here so that you get a vertical asymptote. Is it possible? Can you think of one? Divide by 0. I mean, to divide by 0, first you need a denominator. Yes? Is that a denominator? No. Nothing's going to make this undefined. So you could put any number you want. So negative infinity all the way up to positive infinity would be the domain of an exponential function. And it is the domain of any exponential function. It doesn't have to be e raised x. It could be 2 raised x. But we do have to be careful if b is a negative number. Things will change. But as long as b is positive, no matter what that base is, you would always use negative infinity to infinity as the domain. Even if it is negative, you can use the domain as negative infinity to infinity, but the range you've got to be careful. The number will never be negative. Do you agree? So I cannot put negative infinity as the term with the starting term. Again, that only applies if b is bigger than 0. If it is negative, then we've got to be careful because a negative number is positive. 0 up to infinity. I'm not assuming anything. If I put, for instance, -2 raised x, things get shaky. Yes, because you will get a negative number. So in this case, when I use e raised x, the range is always positive numbers. Now that I wrote the range, you can tell me, does the exponential function have a horizontal asymptote. I'll give you a hint. Did we all find erase x on your calculator? If not, we can recalculate. So, modes of computing. So, when you look at that negative number up there, oftentimes students start thinking, oh, maybe negative value is positive. Yes, naturally, you are looking at a negative number. To avoid that confusion, recall that you can write 2 raised to -1 as 1/2. Agree? Yes? Yes. Okay. So you can rewrite e raised to -x as 1/e raised x. What do we know about e raised x? E raised x can take any value from negative infinity all the way up to positive infinity. Agreed? So, naturally, the domain negative infinity to positive infinity. What do we know about the range? The range of e raised x could never be negative. It can never equal 0. So there is no way you're going to get to pi by 0 because that never becomes 0. If the denominator is always a positive number, is it possible for you to get 1/e raised x to be a negative number? If the denominator is always positive, that will never be a negative number. So still 0 to infinity. If the domain is the same, the range is the same, and both of them are exponentials, the horizontal asymptote has to be the same. So y equals 0. X-axis. Yes. So as long as you have e as the base, you can change that x to x, negative 2x, positive 2x, doesn't matter. These will be satisfied always. So last case, we drew e raised x, and the intercept was at y equals 1, the horizontal asymptote, x-axis. E raised x. When you graph an exponential, what should you put? Something important. Right. Good. And graph. While I was standing right next to Beru and Kiki, Beru said, it will flip. That's probably what we were thinking. That's flipped, right? But even though the curve flipped, the domain is still the same, the range is still the same. Agreed? Now, if I change that new, experiment to, for instance, negative x divided by 2. Good. The curve is still the same. All you did is you transformed. Just like, with parabolas, you have the same parabola. You can stretch it, shrink it, compress it. We're doing one of those. That's all. And you can do that. Still the same. Yes, nothing changed. Will things change if, for instance, got rid of divide by 2, I have e raised x, and I'm adding plus 2. Will the range change or will it stay the same?
It'll change.
It will change. Why is that?
You're basically adding a vertical translation by 2.
I'm adding something to y-axis, so it will change. Will the domain change? No, it will remain the same. Calculator is your body, so saying nothing anytime you want. But to change, maybe go from -5 to 5 and graph. Good. Yes.
So whatever the say constant is in x letter, whatever they can y intercept, and then it is the x. So it's that it's e to the x is the x to the top 0. So is that
The y-intercept would be 1, but the asymptote will be along the x-axis. Here is another case. Two minus e raised x. Will the range change? The range, yes. Will the domain change? No. Let's see. What just happened? The domain is the same, but what about the range? It is not the same. You have negative values. So there is this idea that will occur in your mind that all exponential functions will have a range from 0 to infinity. I completely agree. That is true, as long as it remains in its base state, e raised x, e raised negative x. B, put any value to raise x, to raise negative x. Fine. If you made any change at all, maybe addition, subtraction, changing the base to a negative number, any one of those operations could possibly change the range. Yes? So when in doubt, use your calculator. With good amount of practice, you wouldn't need a calculator. But until you reach that point, do keep in mind the range is not always 0 to infinity. Yes, or an exponential function. Going along the same lines, the domain is not always negative infinity to positive infinity. As long as e raised x is just e raised x on its own, life is good. But the moment something changes, you've got to pick up. Here is a good scenario. 1 divided by, what should I call it? Before I start typing, parentheses. So 1 is minus, going to do e raised negative x, e raised negative x. Is there a value of x which will break that function? Alexa, what is that value of x? X is equal to 0. When x is equal to 0, we know e raised negative x is 1, which would give me 1 divided by 1 minus 1, which is 1 divided by 0. Big no-no. Let's see. Do we have a vertical asymptote. Yes, vertical asymptote at x is equal to 0. So when you write the domain, you can still write it as negative infinity to infinity. Yes or no? Nolan, I can't hear you.
No.
I didn't speak. Yes. So the domain is not negative infinity to infinity, rather, how would you like Nolan?
Negative infinity to 0, u 0 to 1.
Good. Negative infinity to 0, union 0 to infinity. What about the range? Can it take negative values? Can it take positive values?
Most.
No?
Most.
Most. All of it. One most.
Oh, wait, never mind. Never mind. I'm
Can it
misreading.
take, yeah, can it take the value 0? Could it equal 0? Never. So negative infinity to 0, union 0 to infinity. What about the horizontal asymptote? Does it change? Or is it still the x-axis? Still the x-axis. Does it change? Is there a vertical asymptote? And what is it?
Why?
Why?
Wait, x equals 0.
X equals 0. In this case, mistakes naturally will happen in writing the domain range, but most importantly, when you miss this fact, don't think about it. You write the range as negative infinity to positive infinity, but it is not negative infinity to positive infinity because y will never be 0. It will get close to 0, but never exactly 0. Are we clear? Yes.